take down one problem. Calculate the current through the circuit. Calculate the current through the circuit. The internal resistance of the battery is negligible. The internal resistance of the battery is negligible. First take down the circuit diagram or the network. We have 2 ohm, and then we have 3 ohm, this is 2.8 ohm. Calculate the current through the circuit. The internal resistance of the battery is negligible. First find out the equivalent resistance of the network. It's very clear that here 2 ohm and 3 ohm are connected in parallel. Reduce the network into single resistance. We have this 2 ohm and 3 ohm in parallel, so it is equal to 2 into 3 divided by 2 plus 3. 6 by 5. Which is equal to 1.2 ohm. That will be in series with 2.8 ohm. Then we have 6 volt. Now this is a simple series network where 1.2 ohm and 2.8 ohm are connected in series. So their equivalent will be 1.2 plus 2.8. Which is equal to 4 ohm. Now the current in the circuit is current flowing through the network. I is equal to V by R. I is equal to V by R. Which is equal to 6 divided by 4. 1.5 amps. The current flowing through the network is 1.5 amps. Next, take down another question. A conductor of length L length L is connected to a DC source of potential V. Potential V. If the temperature of the conductor is increased, if the temperature of the conductor is increased, keeping V constant, explain how do the following factors vary in the conductor. Explain how do the following factors vary in the conductor. A conductor of n length L is connected to a DC source of potential V. If the temperature of the conductor is increased, keeping V constant, explain how do the following factors vary in the conductor. So the first factor is resistance, and the second factor is electric current. Conductor of length L is connected to a DC source of potential V. If the temperature of the conductor is increased, keeping V constant, explain how do the following factors vary in the conductor. Now we know on heating the conductor what happens to the resistance. For a conductor, on heating the conductor, the resistance increases. On heating or on increasing the temperature, the resistance increases. And what happens to the current? Because the resistance increases, current will decrease. I is given by B. I is given by V by R, and here V is kept constant. V is constant, and we know R is increasing. Because the denominator increases, the current decreases. So on heating, I decreases. The electric current in a circuit decreases, or electric current reduces. Decreases. This is how the different factors vary. Resistance increases because the R is increasing, current will reduce. We have I is V by R. So resistance increases means this is constant, the numerator is constant. So keeping the numerator constant, if you increase the denominator, your I will reduce. The current in a circuit reduces or it decreases.